All right, so here we're going to go over basic how do you attack renal acid-based problems. This is a very common topic. So the first thing is you look at the history and physical. And the history and physical, the problem will tell you what's going on with the patient. For example, if you have a patient that comes in and has any kind of lung problem, so if they have any kind of lung problem, like they cannot breathe and so forth, then you know that they're not able to blow off the CO2, so they're in respiratory acidosis. So any kind of lung problem, any problem with the muscle sedatives, you know that they cannot breathe as well, so they're going to give you respiratory acidosis. Now, if you have a patient that has taken some sort of they're in DKA, diabetic ketoacidosis, they have a lactic acidosis, they have taken aspirin and it's been a while, it's not an immediate thing. Remember, when you overdose on aspirin, early is going to be if you overdose on aspirin, early is going to be respiratory alkalosis. But then after a while, if it's late, some hours into the dosing, you're going to get metabolic acidosis, iron tablets, lactate acidosis, ethylene glycol overdose, like they have ingested toxicants. If they have advanced kidney disease, they have uremia. All of these things are going to lead to a anion gap, increased anion gap, and they're going to give you metabolic acidosis. You can see right here, metabolic acidosis. Now, there's also something in normal ion gaps. For example, you're in metabolic acidosis, but the ion gap is normal. Why is it normal? It is normal because you have chloride, which is a negative ion. So if your bicarb goes up, your chloride goes down to make sure that the sum of negative ions is still the same. Similarly, if your bicarb goes down, the chloride ion is going to go up to make sure that you have a normal anion gap. That happens usually in hyperalimentation, a patient that has been in the hospital getting IV fluids, Addison's disease, renal tubular acidosis, diarrhea, if they're on acetazolamide, spironolactone, and any kind of saline infusion. Now, if you have a problem that has hysteria, like they're breathing really, really fast, you're going to get respiratory alkalosis. Tumor, lung disease is going to give you respiratory alkalosis. Overdosing on aspirin is going to stimulate the medulla, which gives you hyperventilation. So that's going to be respiratory alkalosis. Pregnancy, respiratory alkalosis. Metabolic alkalosis is going to be when you have loop diuretics, vomiting. Remember, vomiting means that you're throwing up. You're just pretty much throwing up from your stomach, right? And your stomach has very high acidic content, so all the hydrogen is being lost. So you get metabolic alkalosis. Antacid use, hyperaldosteronism. Why hyperaldosteronism? Remember that loop diuretics mean that you have more in the collecting tubules. This is the collecting tubule right here. This is the collecting tubule right here. In the collecting tubule, you have more sodium reaching, more calcium reaching, more chloride reaching. And eventually, aldosterone puts these channels that bring sodium into the body. Potassium is going out. And because of that, you also have something very special. You have this potassium hydrogen channel on the other side of the cell. So because you're losing so much potassium, your body tries to bring in some potassium, and in order to do that, it has to spit out a hydrogen. And because of the hydrogen, that means that you are going to be keeping a lot of the bicarb in your body. So this is the history and physical. The second step is that you're going to look at the pH, CO2, and the bicarb. So you know that the normal pH is 7.35 to 7.45. You're also going to do something where you take the bicarb concentration that is given in the problem, and then you add 15 to it. You add 15 to it, and you look at the CO2. Is the CO2, this is what your CO2 should be. Is it what it is in the problem? If it's not, if it is, then you know it's compensated. If it's not, then you know there's going to be a secondary, a primary, two or three other mixed disorders present. The thing to look at is that if your CO2 is going up and the bicarb is going up, or they're both going down, they're both going in the same direction, that tells you that this is a primary disturbance. If they're both moving in the same direction, primary disturbance. However, if they are not moving in the same direction, one is going up, the other one is going down, that should tell you that, what's going on? Disturbance. If one is going up and the other one is going down, they're not moving, that tells you that this is a mixed disturbance. There's something else present. If one is going up, the other one is going down, that tells you that this is a mixed disturbance. Okay? Again, if it's not compensated, then you know it's a secondary, there can be one or two disorders present. When I say normal values, another thing to look at is lab errors. So the normal value of CO2 should be 40 and the bicarb should be 24. Usually, you're looking at what's happening in the pH, CO2, and bicarb. If they're all abnormal, fine. If one of them is normal and two of them are abnormal, all right, no problem. But if two of these things are normal, when I say these things, I mean two of these are normal and one of them is abnormal, that's not possible. It's going to be a lab error. So be mindful of that. Now look at the anion gap. Anion gap is whatever the problem's anion gap minus 10 divided by 24, which is what the bicarb should be minus what the bicarb is given in your problem. What is an anion gap? Anion gap is basically sodium minus all the negative things, which is a chloride and bicarb. So that's your anion gap. If it's greater than 18, then you know you have a metabolic acidosis. You might have other things in this problem, but you definitely have a metabolic acidosis just by the fact that your anion gap is greater than 18. Now, the fourth thing to do is to look at your delta delta, right? Delta delta is, delta delta is, I confused you guys. So anion gap is this. If it's greater than 18, it's acidosis. This is a delta delta problem. So maybe I should put it in a different color, huh? Excuse me. This is how you find delta delta. Delta delta. So delta delta, if it's greater than 1, and I know firstly it says greater than 1, but my professor said it has to be much, much greater. So 1.6 will give you, means that you also have a metabolic alkalosis. If it's really, really small, like 0.6, less than 0.6, or 0.125, then you also know you have a metabolic acidosis. So this should give you an idea of how to approach these acid-base problems. Remember, if you go about it systematically, you should not be able to miss these easy problems, okay? All the best.